Hi everyone. In this video I want to talk about two different types of functions. I want to talk about square root functions, and rational functions. Now this doesn't mean rational is like reasonable. Rational functions are ratios of polynomials, essentially. They're ratios of functions. Well, let's first talk about square root functions, though. Square root functions, they look like this. Say the square root of x. So this is like y equals the square root of x here. And now, when we're calculating a square root, what we're really doing is we're saying what number times itself gives us this number. So for example, the square root of 9 is 3, since 3 times 3 equals 9. That's the square root of 9. It's 3, because 3 times 3 is 9. And next, if we want to think about something like, let's look at another example. Let's think about the square root of 0. Well, what times itself gives you 0? If you think about it a little bit longer, you'll get the square root of 0 is 0, because 0 times 0 is 0. Awesome. So the more you play around with these, the more you'll see the pattern. But now let's try to think about what the square root of a negative number would be. So let's say we have the square root of a negative. It doesn't matter what the number is. It's just a negative number. It's a particular fixed negative number. We're going to try to take the square root of it. It turns out this is not possible. Let's try to think about why. Let's say we wanted to take the square root of -1, for example. What we would need is we would need a number times itself to give us -1, right? To give us -1. So a number times itself giving us a negative. Let's try to think about why that can't happen. Let's consider a positive number. Positive times positive. So consider a positive number times a positive number. What do you think it's going to turn out to be? Well, take any two positive numbers and multiply them. You get a positive number out. Now, the only other case to consider is where you have two negatives, right? Because they got to have the same sign, since you're just taking something times itself, right? So this could be like -3 times -3, for example. If you calculate that, it turns out the two negatives cancel, so you end up getting another positive. So if you think about it longer, this is exactly why you can't take the square root of -1. It's undefined for now. We will define it in the future, but this is undefined. So square roots of negative numbers are undefined. So what we always do as a general process when we're solving for the domain of a square root function, we're trying to find that domain of a square root function, what we do is we take the thing under the square root. We take the thing under the square root right here. We take x, and we just let it be greater than or equal to 0. With a slightly more complicated example, suppose f of x was the square root of x minus 1. We take the thing under the square root, we set it to be greater than or equal to 0. So notice I just took x minus 1 and said greater than or equal to 0. And then we add 1 to both sides to solve it. So we get x is greater than or equal to 1. So this is the domain of this function, this square root function. So notice we can plug in 1, but we can't plug in anything less than 1. Because really what we did is we took this graph of the square root of x and we shifted it 1 unit to the right. Now I won't get into what the graphs look like in this video, maybe in a different video, but for now, let's go ahead and let's move on to rational functions. I'm going to clear the board and we'll do that, so be patient for a moment. All right. Oops. Anyway, so we've got rational functions now. Rational functions are just ratios of polynomials. That's what rational functions are, more or less. I'm being a little bit informal, but that's essentially what they are. So it means you have a polynomial on the top, polynomial over a polynomial. And remember, polynomials are things that have integer powers. They're functions that have integer powers. So, for example, of a rational function, so an example of a polynomial is just like the number 1, for example, or x squared, or, there's so many examples. But here's an example of a rational function. A rational function could look like x plus 1 over x minus 2 times, let's say, times x squared. This is a rational function. It's a ratio of polynomials. This on top is a polynomial, and then this on the bottom is also a polynomial. So therefore, this is a rational function. And now, the next thing we want to do is just briefly touch on what the domain of rational functions would look like. Well, for the domain of a rational function, the key thing you have to remember is that you cannot divide by 0, just more generally, right? Division by 0 is undefined. Division by 0 is undefined. Now, what does that mean in practice with this example? Well, if we focus in on our denominator, the part that we're dividing by, I'll take this down here, we would need this to not equal 0. So we need x squared times x minus 2 to not equal 0. Well, when does it equal 0? Well, there's something called the zero product property that says that a product of two things equals 0 if and only if one of those things is 0. So if one of these factors is 0, then our function up here is actually undefined, because then we'd be dividing by 0. So we just solve where this thing does equal 0, and those will be the points that we take out of our domain, that we exclude. So here, x squared is only 0 when x is 0, and x minus 2 equals 0 when x equals 2, right? So if x is 0 or if x is 2, our function's not defined there. Our function, we cannot plug in either of those values into our function because it will be undefined when we try to do that. We will be dividing by 0. So now we write the domain in the following way. I mean, you could say it in a couple of ways. I'll give you a couple of ways to see which one you're more comfortable with. There is interval notation, which is the hardest, and then there is the notation I like. So let's do the notation I like first. So any real number, the set of all real numbers is this symbol here. It's this double R. And what we do is we take out the elements, so we do minus the set of the elements containing 0 and 2. The set containing 0 and 2. So we take the real numbers and we throw out 0 and 2. It's like R minus the set 0, 2. This is the domain of this rational function. Alright guys, I think that's it for this video. I just wanted to talk about and introduce square root functions and rational functions and their domains. In the next video we'll get into chapter 6, which is going to dive deeper into rational functions, but I wanted to touch on them here first. So I hope you guys have a wonderful day.